All right. So, time to get all this reined in. I gotta reduce a lot of these wires, and fortunately, I have figured out a method for doing so. Bring up the schematic. So, I realized I could wire all of the electronics, well, the crystal LED, the emitter LED, and the blade LEDs. I can wire them all in sequence. So instead of 3 data wires for all that, it brings it down to just 1 data wire. And I'll daisy chain their power as well. And that'll just mean 2 power cables instead of, up to, well, I did have it down to 4 before, but now it'll just be 2. Before that, early ones, there was almost like 8 wires for power, but, live and learn. And you can see here, I'm going to try to make it so that the top is disconnectable via disconnecting these, just by connectors. Even if I can't do that, I'm pretty sure. So I'm thinking these 2 right here connectors are what I'm going to go for. Let me get the top part here. There. So this one for data and this one for power. In fact, I'm going to get a nice clean one. There. So that for power and this for data. And I said I only need 1 data, but there's also the blade contact pin. There's blue wire. I want that coming down. So, well, that's going to come down. But first thing to do is to, pull everything out and desolder all the wires that are currently leading to the top. All right, and push that down. I should be able to just push out the core. There we go. It's a bit tighter a fit than the original, but that's fine. We're also going to see what we can do about bringing some of these in a bit, shorten things up a bit. I'm also going to try transferring some of this soldering to the top so that the connector can just be sticking out of here. And then when the time comes, you just push it right in there. Also see if we can possibly get the USB port hooked up, which is going to require some careful gentleness. All right, first things first, let's take off some of this Captain tape. Is that enough to, almost enough to free this up? I guess it's all got to come off. All right, that's life. Put the speaker up here. So I definitely want to change this so I have enough slack to pull this off, but I don't need this much wire. I'm going to leave it that way so I can have it out in the open like this. All right, let's remove the SD card. And let's remove everything going to the top. And we'll see about simplifying the handle. All right, let's remove this wire first. What is this even? Oh, this is, well, at least was one of the data wires. Waiting for it to heat up. scrape off the top of it. All right. There we go. Nice and easy. We'll put that wire over there for safekeeping. So I suspect we'll use it again. All right. There we go. All right, let's do this one at a time. First off, we got 2 power cables running here, so probably this whole thing is going to be coming off. Yeah, and that's fine. Let's get this disconnected. There we go. All right, less wires. Now you see here we got all this blue wire is for this switch, but I don't want to detach that quite yet. Right. Let's do this one first. This black cable is, well, I don't want to say ironically, but it's just happens to be exactly right length for reaching the battery pack, so I don't want to muck with that. All right, now we're going to remove that one. We won't need this wire at all anymore. This all of it's going to run back to just these 2 pads rather than some to here or some to here. All right. Now let's get this one off. Very good. All right, top is disconnected. The rest is just bottom stuff. So this here is what holds the power switch and will hold the USB. You can see here the USB slots through the top here. And then beneath, we just got some exposed terminals right there. And you know, there's enough operating room there. I might be able to do that in situ. So let's start with that, because I would like to have that USB port up and running. All right. I'm opening up the schematic on here so that I can double check what wire colors I picked. Got to wire up 4 wires, and I should be good just using 28 AWG for all of these. This isn't going to be a high amperage circuit by any means. Just needs to promote data communication. All right. Black, green, white, and red. So where's the 28 AWG? I think it's this box here. Here we go, 28. All right, well, black, red, green, and white. Got those spools out. So as usual, red is our voltage line. Just cutting the wire right now. All right, and as usual, I am going to be using way too much wire in the interest of having more than enough. But let's get some solder on these pads first. Not gonna lie, I'm pretty happy with that. All right. What a weird phrase. I'm not gonna lie, as if somehow lying is an option or would somehow accomplish anything. Right. Almost got all the wires cut. So wiring this up is actually going to be really straightforward. There we go. It's going to be pretty straightforward because on the chip, all of these particular circuits are nice and exposed. Well, pads connecting to those circuits. The only exception is the ground terminal, which, as I understand it, I just need to connect it to literally any ground on the board and it will be fine. Just nice, tiny little exposed. We don't need a ton. There we go. All right. Well, I guess we'll start with the bottom one. So this is going to be more or less at a right angle how these wires come out. So I'm just going to solder them up right, just like that. All right. All right. Here we go. Just going to use the magnifying glass. I don't see any shorts. The black one's not in good. All right, let's do that again. That might do it. Yeah, I think that looks good. All right, let's see if we can make it fit in the switch though, because this needs to all go in through the top here. There we go, now at the bottom. Looks like everything survived okay. A bit of a tight fit, but... And if it comes down to it, I may put some hot glue in there to hold this still. I'm pretty sure that this is going to not come out because of that those soldered wires. But those should not be structural in any way. Now, my only concern is like when pulling a USB cable out of this, that will muck with that. So we got this through this, and then we can push all 4 cables through this. So just like that. So these are the cables for the power switch, well, the power and the auxiliary switch, and potentially also the once I get the correct switch, the light there. And these will be for the USB, which we should be able to just rig up with just enough length that the proffie board can be pulled out like this. I don't want to go any further than that. And then when we push it in, these wires just bunch up in there. So, except for ground, which I don't know for sure where that's going. These all need to be that long. I'm going to throw these wires in the box for the 18 gauge, so that way I never forget what gauge they are. All right. So, all right, you can see down there where the USB port wire comes in. Wires come in. Pick it up, slide it in. Yeah. Yeah, I think that'll work pretty good. Except that I've done this upside down, which I think I'm okay with. Yeah, so I had been wiring it up like this, but really I should be wiring it up like this because the contacts for the USB port are only here, and I don't want to have to swing them all the way around to the underside. So I'm actually going to desolder everything else in the name of, well, I got to reshorten all these wires anyway, so might as well just get right to it and pull all the wires off. All right. Hey, the proffie board is finally free. All right, so we're wiring it up like this. So the SD card will be on the bottom now instead of on the top like it was before, and that's a-okay by me. It really doesn't matter one way or the other. It'll make wiring a few specific things easier. All right, well, part of me doesn't want to wire up the USB until last because they're going to be, the ports for are way over here. And that means I'm going to have to wire around those wires the whole way if I go that way. So I think it'll be a lot better if I, well, basically just if I don't do that and do it last. So let's adjust all these guys and get them to good manageable lengths. Now, fortunately, this black one, the negative, the ground terminal. Where's ground? Ground's these two. there's the ground terminal. No, that's not the ground terminal. Ground, these two. So these two on the top are ground. So we're going to wire this right up to that. I'm going to Alt-Tab over to my wiring diagram because that'll give me ground. Yep, all right, grounds. We know this to be self-evident, that all grounds are created equal, but that doesn't stop anyone from double thinking everything. All right. Could put a little more solder on these guys and bridge them together. I'm going to bring in this ground cable. Actually, I'm going to flatten it out with the iron a bit first. Ooh, that's not good. Don't be doing that, Matt. All right. There we go. That ground is connected. And now for the battery connector. So ground, and well, it says 5 volt. Which one's the battery? That's what I thought. All right, it's the one right next to the 5 volt is the battery connector. And I'm gonna clean up this cable a bit too. Nice. I'm actually gonna trim down the exposed metal a bit because it doesn't need to be that much. All right. There we go. We have power again, which really not a great idea to have the battery in while I'm doing all this. Heat does transfer. I doubt it would be a problem, but I'm not risking it. So these two wires, they could be shorter, but I'm not going to make them any shorter because I don't want to risk that. Power switch and stuff, I could redo all of that, so it's not a huge deal. So the question right now is, all right, that's got to be all the way down for the case to be able to fit over it, so it has to go along the bottom. All right, let's just measure these, well, not measure, let's figure out where all these connectors are going. So the green wire, I was going to button 1. Oh, button 1 and 2 are way down here, right? That's nice and simple. All right, the one on top is 2. The one on top is 2, the bottom is 1. All right, I'm actually gonna loop these under here. All right. Green to 1, so that's where I'm gonna send that. That's enough. Button 2, button 1. Yep. go, button 1. And then blue is button 2. We'll go right here. All right. Just a little bit, that's all I need. All right. All right. Nice and tight. Just a little bit long. All right. And then black, where was black going? This black was going to LED 4. The other one's to battery ground. Well, I guess I could actually just run this straight down here if I really felt like it. But I don't want to muck with that down on the bottom, so just put it to here. All right, well, it's not going hot. So gonna apply a little solder to the just put a little bit more on there. There we go. All right, look at that. Power all these wires. So, leaves me with just enough to pull out, but not a huge amount of wires in here. And we just can tuck everything right here with one piece of tape when everything's pulled in. Excellent. So I know these keep looking like almost damaged to me, but then I get them in the light and they're just fine. So it's just the trick of the shadows that's going on here. All right. Well, that wires that up. We still gotta get the speaker situation well situated. Probably gonna just do it on the end like that with some double-sided tape. These are going to be an easy attachment at the end though, so I'm not doing that right now. All right. I mean, this is already way better managed, and we're halfway there with the switch and USB wiring. Fantastic. So I'm going to put that to the side. Put all these switches to the side. Dump all this extra cable in the box. All right, let's get this open so that we can redo what we need to redo inside of this. Also, I successfully 3D printed the spacer that I'm going to need to put in here to make sure that the emitter stays at the top, since that is not a guaranteed with the way things are now. The pressure fitting of it doesn't seem to quite work without the base of the emitter holder fully screwed in, which will not fit at the moment. Oop, there we go. All right, well, let's yank all these through. And we'll, there was this, this is where the data line was. All right, let's extract this. So with the way things are going to be set up now, there is a, oh, well, thank goodness we don't need that anymore. There is a resistor in data line 1 on the proffie board, which means I won't need a resistor here like I just did. I have plenty of spare resistors if it becomes necessary, but as it stands right now, I should not need that, he said, hopingly. Data in, data out. So we are going to need a second wire here, but this first. Let's work on this first. All right. Put the shims somewhere safe. All right, this will be great because right now we're shoving 7 wires through this hole that was really only designed for 3, and we'll get it down to 6. What an amazing reduction. It actually should work pretty good for what we're doing. Well, actually, while we got this here, just do a quick fit test. So this is designed to go in here. Well, I'm going to need to reprint that because I'm just realizing now my measurement took this all the way to the top, but there is thread here that I need to screw down into. So that's all right. I basically just need to measure the thickness of this. And it doesn't even have to be precise. All right. Width-wise, that's perfect. I mean, that's what happens when you measure stuff. It's perfect. Now, I left it open on one side so that, so I could slip it around and off, oh, come on, the cables as needed. There we go. Without having to pre-put them through. And also it leaves one end really open for the cables and it's loose enough to be able to spin around. But let's figure out how much we need to reduce that by. So we screw that in, and when that's all the way screwed in, goes to about there. So now we take my calipers, which are here. Take a drink of water. All right, zero that out. It's basically from just below the second thread. It'll be okay if it's a little too big, because then it'll actually apply more pressure, and I think it'll actually work out better. Heck, I could even use it to adjust. Oh, I could use it to adjust how tight this gets. there. 1, 2 screws. All right, let's not muck with it too much. 3.8 millimeters, 4 millimeters. Doesn't even have to be a tight fit. It just has to be enough to hold whatever's going on at the very bottom. All right, well, I'm gonna fire up my slicer and just shrink that. No, I'm gonna edit the model. I have all this modeled in Tinkercad, which I'll upload the final model somewhere once I have this. All right, so I need to reduce it by 4 millimeters, currently 10 tall, so down to 6. Export, STL. Slice plate, print, upload and print. Now this is a really simple shape, so this is supposedly just going to take 5 minutes to print. So I'll let that go, toss the old one, and while that's going on, we work on removing the unneeded wire from the, well, actually we have to do 2 things. We have to remove the unneeded wire, and we have to bridge 2 contact pads, which will change this from being 2 independent LED circuits to 1 in series LED circuit. Put those over there. Very good. All right. What's the best way to get in there? From this side. So what we got to remove is this center white wire. This is the quote-unquote data 1 wire, which once we adjust these to be wired in series, this will become number 2. Actually, I need to look at the pads where. Oh, it's going to be both. All right. That's good. The angle of approach is more or less the same for both of them. All right. So, need to remove this. So I'm just going to bring this in to center. Got it. But in the process, I think I bridged these 2 pads, which is not good. All right, I think that did it. I need to double check the pin on the other side of that. Looks all right. I'm just gonna all right, good. So now what I need to do very carefully is there are 2 pads right here that are barely separated, and I need to join these 2 with just a little bit of solder. So see if I can pull this off without making a mess. Well, that's bridged both of those and the resistor pad next to it, which is not what I was going for. So I'm just carefully I may have done it. Use the magnifying glass. it's not shorting. Though that resistor pad's open anyway, so I don't really know if it would be a problem if that shorted. But I appear to have shorted the pads. It's just a, yeah, I think I got that, and that looks better after the second try right there. So there we go. Haha. All right. All right, a little bit of extra white wire. I'm sure we'll need that soon. So there's that. Now I'm going to check on the 3D printer. %0 done. So that says to me that it's still calibrating and doing all the bed tests before printing. That should take care of the changes to this. So let's see if we can get this back in here. So yeah, only 4 wires now. I'm pretty psyched, especially since like initially it was like 8 wires, because you're using 2 wires each for the power and the ground. And I changed that by just switching to a thicker gauge wire. And that thicker gauge was able to fit better with everything else. And switching all of the data wires to a lighter gauge wire, which should have been my way I went in the first place, but only 1 more wire than what it was designed for. So I'm pretty psyched about that outcome. Getting things a little closer to how they should be. Yeah, part of me is considering just making a wholly custom mount for this, and I might still do that, but I mean the fact is this works, and at this particular angle actually fits. Before it was bulging up just a little bit on one side, but I didn't think there was a way to make it fit properly, but I'll take that kind of providence. Which may mean that this is now bulging enough that it might just stick in place. Let's pop it in. Now that still moves too easily. If I can just push it like that. I mean, all it's ever going to be is these, but it'll slowly push it down. Look at that, all those pins nice and exposed. Man, this has been a real journey. All right, so what I have to figure out now is that with the crystal chamber and the, where'd I put those LEDs? There's this LED and this whole thing here. This needs to twist onto this shape, but this has to go through here and through this hole, and so by virtue of twisting this shape, it wraps the wires around. But now I'm wondering if there's some way I can change. So if I solder these into here, because I want to daisy chain these onto this chip and then just have one set of wires coming out this chip that then goes to the base. Keep it nice and simple, so there's just 2 simple connectors to connect the far end to the base with the chip. But I need to figure out a way to do that so that this is at least somewhat maintainable. I mean, if everything works right now, and I put this together and solder everything down, I don't know how much reason I'll ever have to actually take it apart. But there's always something. There's always some kind of maintenance. And if I made any mistake, I have to disassemble it. And I would really prefer to avoid having to completely desolder it in order to open it up. So, especially since we're still waiting on the 3D printer, I'm gonna, oh, you know, it'd be fun if I bring up the 3D printer. I can add that as a source and we can actually see it doing its work. Oh, and we're too late. It literally just finished, so I'm gonna go grab it. And the wonders of modern technology. Need a part, just think of it, and a few minutes later, there it is, it exists, just a little bit shorter. So, should be able to put that in there. This feels a little looser. Oh yeah, I could see here on the side. Yeah, this is what happens when you get stuff off of the build plate too quick, it warps. But fortunately, that doesn't matter, because all that needs to do is apply pressure and make contact with this. So, let's do some experiments. So, normally I'll put this on here, carefully twist it together. It's only 2 twists around that this needs to make. So, if I do this first, put the shims on. If I do this first, then that's there. Oh, my shims. I made a mark on this on what I thought was the right side, but it was actually the opposite side. So, oh, come on. All right, I'm actually going to counter twist it a bit. Just a bit. All right. And that's nice and solid in there. All right. Yeah, I don't know how to make this in a way that's Gonna make everything happy, especially since the adjustments seem to make it so that this is stopping on the opposite side of what I need it to stop on. But that does seem to indicate that it is possible for me to screw this on. Oh, I wonder. All right, the side with the stuff. I'm going to put the thinnest cables down on the bottom. Put this on top like that. I mean, that's on, and I did it in a way that didn't require moving these wires around, so it says to me this is feasible. All right, great. Great, great, great. So I want to leave a little bit of slack with this, like something like that. So let's slack all these up a bit, and then where's the cover piece? Goes in this way. So let's see if I can fit this shroud over this much slack. I think I have it upside down. Goes this way. It's a tight fit, but it's working. I think I'd rather have that tight fit than that's a fair amount of resistance. So what's going on there? Is it just the wires? If I straighten these out, is everything going to fit? Okay, so the shape on the inside here, the shape on the inside, these wires here are causing a problem with it. So let's just see if I can, right, bottom screw, bottom screw, bottom screw is on this side. So let's get it down over it. And then, yeah, it rotates to the side fine. All right, so just need to do that, and then I can push the wires over. Get this cap screwed down again. This doesn't need to be super tight. It just needs to stay on and hold in place. What a beautiful ribbon of cables. Oh, a name for the helping hands. You know, I hadn't thought about it. There's those helping hands in Labyrinth, but they're just called helping hands. I don't know. You know, I'm looking at it, and like the pincer hands and the shape of this, it's reminding me of something, and I don't recall what. I'm going to ponder on that. Let's get these cable slack in here again. This is on the opposite end. All right, it's down. And rotate. And there we go. And actually we got just enough here for, well, this one's the only one that isn't going to go in there because this one is the saber detect. This is the data wire. These three are going to wire up to this. And then data black boot, check. Oh, right. I need to apply a new white data cable to this chip. In fact, while I'm at it, let's get more solder on all them chips. In fact, I'm going to take off the existing wires. Making great progress. I suspect once we get to making the connectors, things might slow down a bit, but all I gotta make is those two connectors. Oh, and I still gotta solder on all the cables for the USB, but there's a lot less figuring out this time. The experimentation of day one is heavily informing where everything is going on day two. All right. Solder right here. All right, so you're gonna need in and out. Well, there we go. Look at that. All right. Get this 5 volts straight in. And actually, let me do the data line first. Actually, let me do the ground line first because it's all the way over on the side. What's the shorter? There. All right. These wires are too long. Let me trim this down. There we go. All right. All right. There we go. Now I just need to solder these guys in, which being able to get in there, that's going to be complicated. I need to run these through this ahead of time. If I need to replace this, I'm just going to redesign it with a split here, and then I can just clip this on and off around cables. Because as is right now, this sucker is going to be on here. All right, to make this work, how long do these need to be? Or more, how short can I make them? I guess about this long. Well, I gave myself some slack. So if I need to yank out a bit more length, I've still got it. All right. Just a little bit more. All right. Well, time to get these suckers in here. All right, I gotta have my cap already on. All right, let's see if I can do this effectively. So I need these to still be pretty straight up and down. Come on, just grab this red one. Keep it out of the way. All right. All right. All right. That's all 6 wired up. Let's see if we can get it all back through the hole. All right. I mean, that's everybody. Now let's see if everybody fits while we shove it in the mount. Well, it's in the mount. All the wires are coming through. And there it is. I just need to line it up the holes, which I should be able to use my... There we go. And now the teeny tiny screws that go with that. So these screws were what held the original circuitry in place, and now they just hold the crystal emitter in place. Now I chose to print the casing for this in white, hopefully that it would reflect more light up into the crystal, which I think's been successful. Oh, look at that. So in theory, these 4 wires This is all that needs to connect to the hilt. Well, the rest of the hilt. Even this should fit on here. Oh boy. Well, that's exciting. All right. You know, I am still hemming and hawing about whether or not I actually want to make a connector. In theory, I can still make all this connect to the top of the board. That's a good length for it, and then it all just slides back in. And it would be nice to just have this connected and working one way or another. This is all more than the amount of cable that I want for this. Throw that 22 AWG in there. All right, well, one way or another, it's wire stripping time. That one's already stripped. A little bit more. Oh, Joe's saying add the connector. I mean, I will be happier with myself now if I do that. And admittedly, Joe would be sick. Would be sick. Part of me wants to solder it on so that I can verify everything's working. But you know, making a connector is not going to muck with that. Or anything to make a connector is going to make it easier if something is going wrong. These are the connectors I was going to add. So this one for the data lines, this one for the power lines, just a slightly larger one for the power lines. All right. All right. Where's me crimper? Also, let's put away these wire spools. Shouldn't need any more wire at this point. I think we're wire complete. I am pretty psyched with how clean that turned out. That's nice. In there special. Did all the work, don't skimp out now. Yeah, I mean, Joe, I am going to have to take this apart and redo this switch when the new switch finally arrives. So there's still going to be more I have to do, but then it'll just have to be the switch at that point. Come on, Matt. It's 4 wires. You can build the connector for this. You can do this. Let's rearrange these. Pretty sure we got room for all the wires. All right, why is it resisting? There we go. Oh gosh, looking so clean. Maybe not to somebody who's unfamiliar with all this, but to me, looking clean. So for these, I'm just gonna crimp these. This is gonna be the I guess the female end. Because it's going to be a lot easier for me to replace the wires in this than in this. So the crimping part is just that much simpler. All right, these I got to look up. I got to check which box, which size is which. So this is the larger box. Okay, these are for the smaller one. And these are for the larger one. Snips, snip, snip, snips. Snips are here. right. With any luck, these are my terminals. And we don't have to redo anything. Crimper. This is going to be the black and the red cable. Now, angling everything can be rather difficult, so if I block the view, you'll have to forgive me. Oh, hang on. Whoa, let's stick it on there for a second. Yeah. I bet that'll actually work fine if I... I hear tell of micro crimpers that are easier to use for this kind of stuff. But of course, I don't have one of those. I don't want to have to trim these wires up, so I need to get this right the first time. And somehow I have dropped and lost the terminal. All right, just a little by hand crimping first. Well, that didn't work at all. I mean, not at all, not at all. It's, is that even the right thing? 18 to 22. This is 22 gauge right here. All right, let's grab another one. All right, let's just crushionate it even more. I'm just tightening that by hand. looking at how this crimper is shaped. Well, that's on there pretty tight. Let's see if she fits in the hole. Ooh, she's in. Look at that. So I used what is technically the smaller gauge size on my crimper, and that seems to be actually doing the job effectively. You can see why people get pre-terminated cables for this stuff. I guess that's part of why I was feeling like, oh man, maybe I should just skip this just because it's such a pain. But it is really nice when it all works out the way it's supposed to. You get a nice professional looking connection. There we go. And then it's clicked into place. Look at that. We have a power connector. Now, the data. Unfortunately, the back ends of both of these are actually much simpler. Basically just solder to these guys and then use heat shrink over them to seal up the connection. All right, there's one connector, two connectors. All right. Oh, and that one just tore everything right off. Okay. Quick swig of water. All right, so this one's already squished up. So throw that away. Here's the other one. I'm gonna place the connector on here. Here we go. I found that working on the other end to solder things together works a lot better if the pin is being held in place by the connector. Trying not to clamp it down completely because it seemed like it almost just like cut the wire off with how much I clamped it before. And this one also just cut the wire right off. Holy cow. I'm going to run out. Well, this is why I put slack in there. Well, that's only for the blue one. The white one doesn't have any slack. All right. I need to figure this out. I need to figure it out with the blue one because that's the one I have a lot of slack on. And if I solve how to do this with the blue one, then I do the white one. So the blue one, 28 at AWG. Right. Weird thing is, I successfully did one of these the other day. It was real easy with this gauge of wire, so I'm not sure why. Not sure what I'm mucking up. I know what it is. I know what it is. There's two different levels of crushiness on this thing. I need to get it aligned so that the smaller crushiness maybe I'm just assing out of my talk. Not very entertaining when I'm just trying to figure out how to line this up. You know, I don't think it is. I don't think it is two different levels. I think it's just there. So I just need to be very careful about how much I crushionate that. Here we go. That worked. I'm so used to my other crimpers where you just, all the power, just shove that down. But this requires a lighter touch. All right, let's do the white cable. Do-dun, do-dun. Do-dun, do-dun. Do-dun, do-dun. Doo-doo, 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 doo-doo. Doo-doo. Just trying to get this gripping on here. All right. One click, two click. And then release. There we go. Nice and connected. And now we slip it in here. That's giving me a little bit of trouble pushing it all the way in. Or actually, it is all the way in. My work is done. Thanks for the proper encouragement, Joe. Come on, get in there. Whew. Well, that sucker's never coming out. Hook up the connector. Bam. There we go. The top hilt has two connectors. Now I have to build the bottom connectors. So I need my 28 blue and white. Do you have any blue and white just laying around? I do. The previous cables, that'll be perfect. Actually use this shorter piece of cable. Wire cable. This is twisted, so this is cable. If it was solid core, it'd be wire. Alright, we've already got some terminations on the end of the blue one at least. 28. Alright. Alright, I shall be right back. Right, blue on this side, white on this side. Oh, still warming up. Right. Blue. Trying to be very quick because melting the plastic is very easy. There we go, blue and white. And now I want to double check my heat shrink box to make sure that I've actually pulled out the smallest size that I have, because even it seemed pretty big. I guess that's it. It's the smallest size I got. Oh, the white cable is not well connected. There we go. It's not going to be, oh, you know, these can be smaller. All right. Cheapo heat shrink. Well, not cheapo heat shrink. I should be using a heat gun. There we go. Hardly the prettiest, but plenty of strength there. And plenty of disconnect. All right. Let's just make sure these are lined up right. Okay, blue to blue, white to white. Good, good. Now it's time to make the other end connector, the black and red. just gonna put a little bit of solder on the black and red connectors, other ends. All right. Red on the bottom. Hee. She's good. Where did I put the rest of that heat shrink? It's right here. Snip it up in half. All right. Well, wonky sizes, but it'll work. No, I should wipe off some of that solder first. So far, this wire is great. Like I've nicked it a couple times and it just doesn't melt. Yeah. Oop, I accidentally nicked that connector. All right. All right. Now the other side needs just a little bit. And it's good. All right. Cool. All right. All that's left now is to trim these up short enough and put them in the wire them to the core. Don't know why I put the helping hands away. In no way am I done. All right. Just need to wire these guys into where they need to be. I kind of want to just like wire them up this short. Not kinda. That's what I want to do. I mean, worst case scenario, I rebuild these connectors, but shit. The negative needs to return here. No, it'll be fine. I'll just have the negative return here, and then this will go right over here to battery. If anything, I'll need to trim it a little shorter. All right, let's. This is fine. This is pretty much what I was trying to design here. I wanted these connectors to be close. To where they need to go. So, always watch your soldering cables. Oh, the power cable for your soldering iron. All right, I'm flipping this around to make it easier to get where I need to go with my handedness. All right, I'm gonna apply a bit of solder to the cable. That's on there. And then this just needs to go to battery ground here. So actually I'm gonna trim it just a little shorter. All right. Let's just put a little bit of solder on. Well, there we go. That should provide power. All right, and now I just need to wire up this one. So one was just going over to free one, and the other goes to data one. Data one's here, so it'll just be a little bit of that. So these cables also need to be very short. So close to the electrical finish line. I mean, once I solder this on, I should be able to plug it in and give it all a test. Well, not the USB port, but that's coming. All right, data one, check. Free one. Oh, come on. So close, come on. All right, let's just give us just a little bit more. Ooh, it's in. All right. Let's give this a shot. Now I've reflashed this with new configuration that is based on this new setup, in that the LEDs are all in a series and hooked up to one plug instead of a lot of sets hooked up to multiple plugs. So, I mean, that should be it. Let's flip it on. We've got the green power. Oh, the SD card's not in. All right. I'm getting a flashing green light. I'm not getting any response out of it. I suspect I may need to hook the speaker back up to see if there's some kind of error message or some such. Speaker minus, speaker plus. All right. It's also possible I have programmed it incorrectly now and it doesn't understand. I should have done the red wire first. All right, plugged in.
Art directory not found.
Art directory. Oh, that's right. I have it set to right. I flashed it with a length calculating saber, which is actually going to be horrible for testing. So I'm going to go reflash this real quick and disable that so that's just a regular saber. I mean, we need to know if the lights work. That's what's more important. All right, USB. Well, it's making noise, but I'm not getting any I'm not getting any. No lights coming out. So I gotta figure out why that is. It could be, I mean, it could be anything. It could be programming. It could just be how it was software wise. I'm just gonna inspect the wiring to see if anything's out. Blue is wired to free 1. Data's pretty sure it's data 1. Yeah, data 1. All right, okay, so the switch is working. That's something at least. That was, oh. We may not have a connection here. Well, that's just on the blue line, though. That's not on the... All right, so that pin came out. I'm going to try it again with that, though. That's just the blade detect pin, so... Maybe this wasn't plugged in enough for it to connect. Hey, oh, thank heavens. All right. I mean, that's fantastic. Let's do a blade test. Make sure. Yeah, look at that. We got light with the blade. All right. Hoo-wee. Ha-ha. All right, so that pin was just preventing it from closing effectively. I should have realized just from the way it look. You know how it is from the way it be. All right, so. Whew. All right, so this was not properly in there. I don't see any damage to it, so I'm assuming it's just not seated properly. So I'm going to take my pliers on my Swiss Army knife. I'm going to give this an ever so gentle squeeze. All right, it's still in there. Oh, okay, that's in there. All right. Okay, connector all the way in. Power up. Interesting. So the blade pin being connected seems to be the problem. I mean, this isn't a huge deal for me. I could just pull that pin and I'll be fine. I'm not really much for swapping blades. Let's flip it off. There we go. All right. I need to apply a little bit of pressure. You know what? Before I do that, I'm going to go look at the documentation real quick and see if there's something about the configuration that somehow is making it not work right. Because the saber turned on as long as that blue pin didn't make contact. So maybe it's supposed to be pull up or it's pull down, and I need to like flip the polarity. Reading documentation. All right, I don't see anything weird about it. So, more research will be needed, but for now I'm going to detach this pin. If for nothing else, because that will help me gain a little bit of a data point on whether this is related to the issue. Because we all saw it, there was light. And then we hooked up the pin and there wasn't. Now the blade detect pin stuff is supposed to only be triggered by like when a pin closes and then a circuit is closed. So that should just look the same as the lack of a wire. So it's strange that it would cause a problem like that. Come on. There we go. All right, let's hook it up. See if that makes a difference.
Smooth Jedi. Team C. Smooth Jedi.
Huh. Oh. Not sure what happened there. It was off and then it was on. So it might have nothing to do with that blade detect pin. Pocket knife. Let's put it back in, and then it could be maybe the crimp isn't good on this. As Joe noted, crimping ain't easy, so. There's still a lot of pressure to get this sucker in there. There we go. All right, reconnected. Power on.
Smooth Jedi.
All right, let's carefully play with wires. All right. And of course, I put the speaker cables on the opposite side of where they need to be. But now that we know that what's working, I can take these off. So wiggling this wire seems to do something, so that may infer that there's a bad solder point somewhere. Maybe, I mean, I'll be honest, like I can't see how the solder could possibly be a problem. I think if it's going to be a problem, it's going to be with the connector I built. But the question there is where? So I might have to break out the multimeter and start measuring connections. All right, speakers off. Well, all that said, I don't see any reason why I shouldn't go ahead and hook up the USB port. All right, where's the ground? Where's the ground going to? Ground is... Oh, ground's right there. So, yet another very short run. Take out the SD card. All right, these are pretty much all the pads we need to attach to. All right. I'm just going to bring up my chart real quick. Voltage. All right, red to volts, which is just going to be, come on, Come on. Yeah, my wife was, you know, we're talking, so just trying to figure out how to. Oh, we got light. We got light. All right. Don't have the sound hooked up, but that's all right for now. This is purely about establishing that the components can fit, and I need to put a little Kapton tape on that because that wire likes to slide to the side. Man, why didn't you put some cable management clips into the 3D design? Because I didn't think of it. All right, let's get this. There, just secure enough. Uh-oh, I don't want this. I don't want this sliding. Dang it. That's what I was afraid was happening. I forgot to screw this part down. Just a little to the left, down, and then over. Here we go. So I just need a little more light up here. There we go. There we go. Top segments intact. Well, I mean, the speaker's not in there, but that's like the part I'm worried about the least. 'Cause that's the easiest part to make working. It's in there. The switch is spinny. RGB appears to be working, so yeah, well, I mean, that establishes that this can work all in the hilt. All that really remains is to get that speaker hooked up. So as much as I am tempted to just say, oh, well, everything's okay. Let's just be happy with that. Let's get the speaker working, and then I think I'm going to be pretty happy with that. It's not a perfect connector, but if I have to recreate the connectors, then I will do that when it becomes necessary. All right. Oh, I didn't test the USB yet. Let me go test the USB. I'm walking over to my desktop computer. I've got the power turned off at the hilt. All right. I'm going to reopen the, I still got the Arduino IDE open. So I'm going to plug this in. Oh. I took out the screw that holds stuff like that in place. So I need to, the screw that provides tension behind the USB port. So I'm just going to put that back in. There we go. It's in. Now, in theory, since I wired it up to the USB port, this should provide charging capability as well, but I tend to prefer charging the batteries manually. All right, plugging. No response. I'm going to try flipping the connector around. And nothing. Oh, and I've yanked out the USB. So, all right, USB is not quite working yet. I'm going to have to do more research, figure out why. I probably need to change. I suspected that I couldn't connect the ground to just the general ground, that I might need to connect ground to like the housing of the USB port or something. In fact, I'm going to do some quick Googling to see if I can find some kind of statement on that. I really thought that the soldering would be enough to hold the USB port in place, but that is clearly not the case. And now I am stuck with the bit of a situation in that regard, because I can't twist with this out like this. Just trying to shove the wires down. Where's my tiny screwdriver I just had? I can't twist this with this yanked out like this. What a horrible design flaw. Yeah, that's not working. It's an annoying issue, but there's a simple-ish solution. This is not great for this. Although I've got enough slack here now, I should be able to just twist. All right. Come on. On the upside, I mean, everything held. I don't see anything being scraped off. Hooray. All right. I'm going to go do a little Googling. Okay. Oh, I know for sure, but I'm just going to solder right to the housing. Or do I need to solder to the housing? Of course I do. That was a ridiculous question just now. All right. Gonna need a slightly longer piece of wire. So I'm going to solder it right to what should be the grounded housing of the internal USB port. Solder, 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 solder. Just use this right here. Well, that's bad. I am back. And forgetting to change the sign again. Right. So I just soldered it to the top of the USB housing for ground. All right, just need to wire these all up now. So green is wired. Pretty sure green's on data plus. Yeah, green data plus, white data minus. Where did I put the USB port? Oh, it's still, it's right there. All right, let's trim up this cable. All right. Voltage, white, and then green. All right. And now I'm going to pick this up as is and take it over to my desktop computer with the Arduino software and plug it in. Well, no response the first time. I'm going to try flipping. It may not actually be reversible. All right, well, this one is really strange, just because this should be the simplest wiring. This is just like pad to pad. And I think I see at least a potential problem. I think the voltage line is touching the chassis, which is what we're grounded to. So this right here, I think this is touching the ground. Let me get the magnifying lens, see if there's any. All right, I don't see any. I don't see any solder shorting it. All right, I need to readjust this. All right. Bring up the chart again. Oh, that's not right in my chart. I mean, that's in there. Doesn't look like it's shorting to any other connectors, so let's go try hooking it up again. All right, USB, it's not working. I need to do more research on that. So I'm not going to do that right now. Instead, we're going to be happy with the progress we've made. Connect up these speakers. Come on, get in there. There we go. All right, speaker wires. Where are you on the bottom? Speakers. Opposite side. USB ports here. Speakers. These two silver pads right there. Speaker plus is towards the back. All right. Oh, learn my lesson this time. Oh, I wanted. There. Here's red. That finally melted the case a little bit. And there's black. So we should have noise. Very good. All right. There we go. She's all the way back. Time to cut some Kapton tape. Oh, I should have fixed the speaker to the rear first, and well, I don't have to fix it. I just have to get the wire lengths figured out. All right. What did I think of this? Just like cut off a big piece, a Kapton tape, and then cut off little pieces as I need them. All right, so that'll live there. That'll be like that. Let's make it so you can see. Let's bring the speaker wires over here. Get that there. Get that there. There we go. All right. That'll hold speaker wires in place. Let's make sure everything's good. We got noise. A bit of housing there. All right, now we get these connectors all shoved in there. And now we got to bring up this piece. This piece on top. a good tester of the spacings on everything. Right. All right. All this needs to be secured. So we'll cut off another piece of Kapton. There. And we'll just happen to cover the positive terminal while we're at it. All right. Gotta really this was fitting before. It's this bulge. This is too much in one place for it. All right. Let's bring all this up here. We'll keep the power cables, speaker cable here. Oh, you know, this is floating around too. Gonna have to secure that. Get that piece further in there. This was always designed with Kapton in mind. All right. Then all this. For safety, I'm going to take out the SD card. Okay, there we go. All right. Scraped off that Kapton tape, like, really aggressively. You know, I've got enough space here. Should be able to shove. Yeah. All right, we had this working just a bit ago. It's not even that. All right, this wad can be done up much tighter, and I think I'm going to have to. All right. All right. Let's slide nice and easy. Now, just got to deal with all this. Yeah, there we go. All right. Just make sure the connectors are all pushed in there. All right. Snapped in place.
Smooth Jedi.
Colors are working. All right. I'm just going to go snag a tiny bit of double-sided tape. If I can find it. I think I left it upstairs. I'm going to go get it. All right. Double-sided tape. All right. go. All right. Handle right here. All right. All right. Wrong hole. There we go.
Smooth gray.
Oh, missing the back bolt. Where's it gone? Where's it gone? There it is. I got spares, so not worried, but all right.
Smooth fuzz.
It's a constant battle right now. This is giving more resistance than I expected. So I'm going to have to figure out why. Okay. All right, I don't like the noises I'm hearing while I'm screwing in this screw, so I'm gonna have to take a look.
Smooth Jedi.
No, but like consulting somebody who knows something, who knows more about this than I do, would probably have been great. I don't like that sound, but I can't get this apart. And there I've destroyed the cable. Damn it. Okay, even with that, I can't get this out, and I don't understand why. At least I can disconnect it. That part's working good. There isn't even contact on the bottom. This damn USB port, it won't go in for far enough. Maybe I need to redesign the core to move a little bit, but as it stands, I have to redo this connector.
Smooth Jedi.
The data plug has come off on the inside. All right, this is going to require a lot more disassembly than I'm happy with right now. So I'm going to need to take a break from this and ponder everything and figure out what went wrong and what I need to do to fix it. Some successes, the lights were turning on with any luck by recrimping these. I'll fix whatever data line issue was happening. I might directly solder the data line to the board just to see what's going on. The connectors might be taking up more room than I'm okay with. In that a little bit of coiled wire might make more sense. It won't make it easy to detach the hilt, detach the emitter portion, but all right, yep, I'm gonna go over my charts and all that and see where this is a problem. This doesn't go down enough. The blue cable has disconnected. That's not optimal. Oh, there's a problem in there. There's a lot of frayed wires coming off one of the ground wires. The is it the one with the one from the that provides power to the upper part? There's some frayed wires, and it's much higher off the ground than I'm okay with. There isn't a room for a connector like this on the side. Okay. Okay. Yep, I'll figure it out. And then we'll be back for part 3 once I do. Thanks for watching, everybody.